Hi, I'm Michelle King, and I am with Colliers Engineering Design. I'm also the chair of the Telecommunications Industry Foundation. Today we're going to be talking about change conditions, and this is based on the TIF White Paper called An Examination of Change Conditions as Defined by ANSI 222H. Here with me to talk about this, I have Kyle Thorpe from Paul J. Ford, Jared Tibbetts from Tower Engineering Solutions, Limmy Racinos from Colliers Engineering and Design, and today they're all licensed professional engineers, but we're going to be talking with them about how to kind of demystify what is a change condition and how to apply it and effectively communicate it to the various stakeholders in the industry. So Kyle, let's first talk about what is a change condition. Can you help us understand this concept and where it came from?
Sure. A change condition actually is introduced by the IEPC and it was adopted by the TIA 222H. And really what it is, it's a tool for us to assess if we need to do a comprehensive analysis of the site based on loading changes that the tower owners or the carriers are trying to do on that given site. You want to talk about kind of how we do that?
Yeah, so what we'll do is we'll look at the loading that's being proposed by the customer, and we'll look at the last baseline structural analysis, and we'll compare the loading. We'll look at what the loading area changed, whether they're increasing the wind area or decreasing it, and we'll look at the weight that's being changed as well. We'll do calculations and determine whether that increase is greater than 5% or less than 5%. If it's less than 5%, we can say it's an insignificant change, and then a full structural analysis does not need to take place because the loading is relatively similar to the previous one.
Okay, now Kyle, you referenced code. What code are we talking about? Let me, what code is this referenced in?
So, as Kyle said, it's referenced in the TIA standard, but they pull their really information from the International Building Code and the International Existing Building Code, which has a specific section in the IEBC about change conditions and how to evaluate change condition. They actually set the threshold at 5% for gravity loads, your weight, and then 10% for your lateral load, consider your wind area. TIA is a little bit more conservative on their end, where they reduce both of those parameters to 5% across the board rather than the 5 and 10. IEPC actually does allow one to look at what the code is actually written.
Okay, now Limmy, you have a lot of experience with both buildings, traditional building structures, and telecommunication structures. How is this concept applied between the two? Is it the same, or are there any differences?
It's a really good question. I think fundamentally they're the same because what you have is a structure that was designed by a licensed professional engineer, and then at some point down the road, 5 years, 10 years, 15, 20 years, 6 months, whatever that is, whatever that time frame is, you have someone else coming and wanting to change the loading on that structure. So whether it's a tower or it's a building, you're changing the loading that the structure was originally designed for, last analyzed for. Where it gets a little different is that with towers, you're evaluating these structures every 6 months, every year, every 2 years. You're having a licensed professional engineer come in and do a full structural analysis and evaluate what the structural capacity of the tower is. With buildings, it could be 30 years before that structure gets touched again. And then at that point, you have really 6 cycles of building code that you would want to have to bring the structure up to code if you had more than a 5 or 10% change. With towers, because you're touching them every so often, you want to look at, is the loading I'm adding, like Kyle and Jared were saying, is that within that 5% threshold or not?
Okay, now Kyle, where do you start with all of this? When do you determine if you need to evaluate if there's a change condition on the site or not?
Yeah, in truth, we really want to start with that, condition assessment right at the beginning. Like we were saying, we really want to take a look at that before we really get into the hard numbers and running the analysis. We want to say, okay, does this even qualify for the need to run a full comprehensive analysis? So that's where we want to start the conversation.
I think the easy button for us as engineers is to say, my customer asked me to evaluate the new loading they're proposing. I'm going to give them a structural analysis. But really, what we want to do as consultants is evaluate what is the change that's actually happening before I ask them for a fee to do a structural analysis. Do I need to do that? Can I say, look, your weight is decreasing and your wind area is only increasing by less than 5%. You don't need me to do a full structural analysis. As your consultant, I can give you this licensed, signed and sealed PE letter saying you don't meet the change condition requirement of the TIA, so you can install your loading with this PE letter rather than full structural analysis.
Okay, so let's get into a little bit more details on the calculations. Jared, how do you actually perform the calculations to determine if there's a change condition? What are the different types of criteria that you're looking at?
So the first thing we're going to look at is the type of structure that's being analyzed. Guy towers are indeterminate structures, and they'll behave slightly differently than a self-supporting monopole will. If you decrease loading on a guy tower, you're not necessarily decreasing the load on it. It could cause the demand to go up on the structure. So we'll look at the wind area of the antennas that are being applied to the structure, sum it all up, and we'll do the same calculation with what the baseline existing is. We'll do the same type of analysis or check with the weight of the appurtenances proposed and existing. And then we'll compare that to determine whether that's a 5% increase or not between those two differences.
Okay, well, you mentioned baseline information. What can you do if you don't have baseline information? Can you still apply the concept of a change condition?
Yeah, if the load change is non-existent, so you're just changing out RUs, similar sized RUs. The load change, there is none. So we can say that's basically maintenance on the structure. And that structural analysis is not required, and that there is no change condition because it's just a maintenance change.
The other thing you can also look at is maybe you have a reduction in loading, right? Because of new technologies that are coming out, antennas are getting smaller. Maybe we're moving technology off the tower into the shelter. So the existing configuration the last time it was touched has a loading configuration of X, and now your new loading configuration of Y is less than that. Well, you don't even have an increase, you have a decrease, and unless you're on a guide tower for monopoles and self-supports, that decrease is only going to make the structure better.
Okay, let's talk about how we would apply this concept of change condition over time on the life cycle of a site. So for example, what if you look at a project coming in, the customer requests an analysis, you evaluate if there's a change condition and you determine that there's only a 4% increase in weight or area, and so there's an insignificant change condition, you move forward with a PE letter on that site. What happens in 2 years when that same project comes back, they've installed the previous loading change, and now you're evaluating again and there's only a 3% increase. Can you still provide a PE letter for that project? How does that work?
Yeah, I think one thing we've got to make sure we got to be careful of though is creating a stacking effect where we're looking at a change condition event and say it goes up by that 3%, and then take a look at it again and it's another 4%. You can't look at them solely individually. You're really looking at them from kind of a baseline event last time the full structural comprehensive analysis was performed.
So in that case, what you're looking at from the last structural is a 4% change. You're looking at 7% from the last time the tower was evaluated structurally by a professional engineer. So then that 7% gets you outside of that window of 5% that Jared was talking about. And now that does trigger a full comprehensive analysis.
Okay, as you know, many jurisdictions have more stringent requirements when it comes to the deliverables required for the analysis of a site, of a structure. Have any of you ever dealt with pushback from a jurisdiction on one of these PE letters that you've delivered to your customer? And if so, how have you successfully communicated with them to help them understand what we're doing here and what the genesis is of our calculations?
So the good thing with what we're doing is it originates from the International Building Code. The allowance for this change condition comes from the codes that are adopted by the jurisdictions. So when they push back, we can point to say, hey, this comes from the building code that you adopted. You said this is what you were designed by. This is where we get it from. So we're still falling within what they're requiring for the design. So we fully meet the requirements of the codes that are adopted by the jurisdictions with the change condition.
Yeah. I think it's just a really good education point. I think Lemmy talked about earlier, we're so used to kind of just hitting those straight analysis spots. They're not used to that kind of section of the code really being used, particularly in the telecom industry. So I think us just having that conversation with reviewers, I think we've all had that experience. We just walk them through it, have pretty good success rate on them adopting.
Yeah, I think the other thing is to help them understand that you take this from the IBC, but again, you have the window on traditional building structures 15, 20 years before they're touched again, whereas towers, we're evaluating the professional engineering standpoint every 6 months, every 1 year, every 2 years. So there's actually a lot more due diligence going into the reviews that we're getting these documents as professional engineers compared to the building industry and the traditional buildings that they're typically used to seeing.
Thank you all for talking to us today about change conditions and helping us understand where this concept comes from and how to effectively apply it and communicate it. I think we all now understand that change conditions and evaluation of them is not only code compliant, but it's something that engineers can do to help be good consultants to their customers as well. And as a reminder, this is based on the TIF White Paper, which you can see referenced at our website below, tifonline.org. Thank you.